Hi, this is Hulan.
And Guillermo.
We are implementing floating point unit and also a branch prediction unit to our MIPS pipeline processor.
From assignment 4. Some of the things we learned throughout the semester are helping us in this endeavor, such as deciding how to test the program, the design, that is, the kind of signals we need to implement for the instructions we require, as well as what modules to add. Currently we have test benched the branch prediction unit, the floating point unit, and
I'll just switch over the screen. So we have right here the schematics for the branch prediction unit and also the floating point unit. If you want to take an in-depth look, you can pause the video, have a look at it. So right here we've screenshotted the a simple program running with the branch prediction unit, and we're predicting 1 right here. It's the second iteration, and then the target address is 28. It's branching right there, and also the unit also is able to detect if it's wrong prediction and then just fetch the regular PC address.
PC plus 4.
Which should have been.
And we added a kind of a doubled up on this. If you see right here, we're actually writing to the LEDs to show that we interfaced with the board. The following is the FPU test bench that was successful. Next, we have the program from the first test bench you gave us. So here is where it finally writes 7 to memory, and then here's the first load word instruction that is going to interact with LEDs and switches. So right here you see the right data is 23D that came from the switches, and then the next cycle you have LEDRs displaying the same thing. And here's the memory.
And then now we'll switch over to our camera and then show the board.
So here's the board. It's not 100% yet, so it might not be just an incremental increase in the LEDs.
So from the program where we just showed on the branch prediction unit, so the store word was storing from $2, and then which should run from 0 to 1 to 2. It was working like a couple minutes ago, but somehow it's not working.
So
but it's still, we're in the process of
debugging.
Yes.
So now, so we're just using, like you said, one of the keys for the clock input, and then that's the reset. So, and that resets.
And then we think that we're pretty good, that we're halfway through our projects. For branch prediction unit, we just do a little tweaks, and also work with the hazard unit where we have to flush at some situations.
The FPU has been test benched. However, the move to coprocessor instruction is not quite there yet. We needed to add another instruction in order to convert integers into floating point standards. So instead, we just developed a module to deliver the information to the floating point register already as floating point with the single instruction.
And then at the end, we just gotta combine both modules and then come up with the whole developed processor where it can process with the floating point numbers and then also predict branches. And therefore, we're going to have performance counter where we could display it on the either LEDs or 7-segment, and we'll have
hopefully we'll have a
faster
processor. Yeah?
Yes, and thank you.